Hello everyone, for today's video, we will be talking about the nuclear fusion reaction and the country and its positive and negative impact to the country brought by the nuclear reactor. But before we proceed to the top 10 countries, let us define first, what is nuclear? In simple terms, nuclear fusion is a reaction through which two or more light nuclei collide to form a heavier nucleus. The nuclear fusion process occurs in elements that have a low atomic number, such as hydrogen. Nuclear fusion is the opposite of nuclear fission reaction, in which heavy elements diffuse and fission produce a massive amount of energy. So here are the top 10 nuclear energy producing countries in 2021. Starting from the rank 1, United States got 91.3 gigawatts of nuclear generation. The nuclear states has a total installed nuclear capacity of 91.5 gigawatts generated by 93 reactors across 30 states. In 2019, the country used this to generate 843 terawatt-hour, more than 30% of global nuclear energy production. And this represents 20% of the country's total electricity consumption, as the US relies more on natural gas and coal for power generation. In the state of Georgia, 2 more reactors are under construction as part of the Volatile project, and these are expected to come online in 2022. After safety violations in the design of the first reactor caused delays, followed by France, 61.3 gigawatts of nuclear generation. France generates approximately 2/3 of its electricity from nuclear sources, a larger share than any other country. These centralizations of nuclear expertise has helped lower nuclear costs in the country and allowed it to generate approximately 17% of its electricity from recycled nuclear fuel. France's connections to the European grid allow it to export more nuclear-generated electricity than any other country. So the country currently has 56 operational reactors that collectively generated 338.7 terawatt-hour in 2020. The French government has vowed to build more reactors to decarbonize its power generated by 2050. At the same time, it will shrink the share of nuclear energy in its mix to below 50% by 2035 by increasing its renewable generation. In 2020, the country's 2 oldest nuclear units at the Fission power station closed due to environmental concerns, and these were originally expected to close with the opening of the new Flamanville 3 reactor, now due to begin operations in 2023. And followed by China, 15.8 gigawatts of nuclear generation. A net installed capacity of 50.8 gigawatts makes China the third biggest nuclear energy producing countries in the whole world. China has 51 nuclear reactors. Although nuclear plays a relatively small role in China's titanic energy system, and nuclear generated only 5% of Chinese electricity in 2019. In the same year, total nuclear power production reached 330 terawatt-hour. China's power system continues to expand rapidly, with 18 reactors currently under construction. And this would add 17.2 gigawatts of generation to the country's power system. Moreover, the constructions of 39 nuclear reactors with a combined gross capacity of 43 gigawatts has been planned. In January 2021, Chinese engineers celebrated the start of operations at the country's first third-generation pressurized water reactor. The Walong 1 is China's first domestically developed reactor designed to be significantly more efficient than existing reactors. Authorities plan to build more of these in coming years. Fourth, Japan has 31.7 gigawatts of nuclear generation. Japan has 33 nuclear reactors in operations with a net installed capacity of 31.7 gigawatts, while 2 reactors, Oma 1 and Shimain 3, with a net capacity of 2.6 gigawatts are under construction. Before the meltdown of the Fukushima Daiichi plant in March 2011, Japan derived approximately 30% of its power requirements from nuclear energy. At the time, Japan would have placed at number 3 of this list. Following the incident, the Japanese government temporarily paused all nuclear reactions for 2 years. A new national nuclear regulator took over monitoring of plants and introduced new checks and practice to prevent any new disasters. During this time, decreased nuclear generation meant an increase in coal power and coal imports. The resulting environmental and economic effects proved unpopular, with the Japanese Business Federation saying, "By stopping nuclear power plants, a national wealth is flowing overseas." Russia 29.6 gigawatts of nuclear generation. Russia has 38 operating reactors with a combined net capacity of 29.6 gigawatts. At the same time, 2 more reactors with a combined net capacity of 2.3 gigawatts are under construction. As part of the Course 2 project, in 2019, Russia produced 195.5 terawatt-hour of nuclear energy, which accounted for approximately 19.7% of its total electricity generated. Before the establishment of the modern Russia, the USSR was one of the original frontrunners of nuclear technology, and engineers constructed Soviet-designed reactors throughout much of Eastern Europe. And today, Russia remains a world leader in fast neutron reactor technology. So the state-owned nuclear power company, Rosatom, has hopes its Proriv project will develop a closed nuclear fuel cycle based on how fast reactors for industrial implementation on large scale. South Korea got 24.5 gigawatts of nuclear generation. South Korea has 24 nuclear reactors in operations with a combined 24.5 gigawatts capacity. 3 of the country's 4 operational reactors lie along the country's southeastern coast, near the cities of Jeongju, Ulsan, and Busan. The densely populated region hosts several heavy manufacturing plants, causing relatively high electricity demand. South Korea generated 146 terawatt-hour of nuclear energy in 2019, while natural gas generated a similar amount. Each of these fuels generate approximately 25% of the country's total electricity, trailing behind coal's 42% dominance of the Korean energy market. The nation has 4 nuclear reactors, Shin and Hanul 1 and 2 and Shin Kori 5 and 6, under construction, with all 4 lying along the southeastern coast. This will add 5.3 gigawatts of net capacity to the Korean grid when finished. Nuclear remains significantly popular in the country, with an opinion poll in September 2021 that showing 72% of the population has supporting nuclear power generation. Canada got 13.6 gigawatts of nuclear generation. Canada has a total of 19 operational nuclear reactors spread across 4 power plants, and most of them located in the state of Ontario. Collectively, these give the country a net installed capacity of 13.6 gigawatts in 2019. Canada generated 94.9 terawatt-hour of nuclear energy, which accounted for 14.9% of the country's total power generation. All the nuclear power plants in Canada feature Canadian deuterium or uranium CANDU reactors, which use pressurized heavy water as a coolant and moderator while using uranium as fuel. Ukraine got 13.1 gigawatts of nuclear generation. Ukraine has 15 operable nuclear reactors with a combined installed capacity of 13.1 gigawatts, while 2 reactors, Melnitsky 3 and 4, are under construction. These pressurized heavy water reactors will provide a 2 gigawatts net capacity when completed. Ukraine produced 78.1 terawatt-hour of nuclear energy in 2019, which accounted for 53.9% of the total electricity produced in the country. The country is highly dependent on nuclear energy and receives most of its fuel and services from Russia. Due to geopolitical disputes, the country proactively purchases fuel from U.S. company Westinghouse to lessen its dependence on Russia. Ninth, United Kingdom got 8.9 gigawatts of nuclear generation. So the UK has a combined with net nuclear energy capacity of 8.9 gigawatts with 13 operational nuclear reactors. So the country generated 51 terawatt-hour of nuclear energy in 2019, which represented approximately 16% of the country's total electricity output. And the construction has started on two new reactors at the operational Hinkley Point plant, with a planned combined capacity of 3.3 gigawatts. And this would generate 7% of the country's current electricity requirements. Approximately half of the country's existing nuclear power reactors will be retired by 2035. The UK government intends to support development of at least one new nuclear reactor. The legislation and funding surrounding this has caused a mixed reaction from nuclear developers, with several projects proposed and cancelled over the past few years. The last one, Spain got 7.1 gigawatts of nuclear generation. Nuclear currently generates approximately 22% of Spain's electricity. So the country has an installed capacity of 7.1 gigawatts generated by 7 reactors. And all of this first connected to the grid between 1983 and 1988, with little consideration to nuclear, however, government ministers have called nuclear plants essential to the country's energy grid and lifted limits to their operational lifespans. In 2020 and 2021, 6 of the country's 7 reactors renewed their licenses for coming years, and all of this would expire before 2035. So the deadline for the Spanish government plan and phase out of nuclear power. Announced in 2018, Spain's government said that the plan to eliminate nuclear power was a social decision and that it would take decades to complete. So Spain currently has 3 decommissioned reactors, and the wave of decommissionings would require significant nuclear decommissioning infrastructure. So here are the positive impact to the country. First is low cost of operation after the initial cost of construction. Nuclear energy has the advantage of being one of the most cost-effective energy solutions available. The cost to produce electricity from nuclear energy is much lower than the cost to produce energy from gas, coal, or oil unless those resources are located near the power plant they supply. Nuclear energy also has the added benefit of facing comparatively low risk for cost inflations, unlike traditional fossil fuels that regularly fluctuate in price. Second, reliable source of energy. While some energy sources are dependent upon weather conditions, like solar and wind power, nuclear energy has no such constraints. It doesn't matter if the wind is not blowing or if the day is cloudy. Nuclear power plants are essentially unaffected by external climatic factors and create predictable and steady energy output. A nuclear power plant in full swing operation can produce energy and non-stop for an entire year, which allows for a good return on investment. Because there is no delay in energy production. And nuclear power plants are also reliable because we have enough uranium on the planet to generate energy for the next 70 to 80 years. While that may not sound like a long time, it is longer than many fossil fuels are estimated to last, and there are other nuclear energy sources being explored to power nuclear power plants. Third, stable baseload energy, you may not realize it. but nuclear energy is widely used in America. In fact, it makes up around 20% of all electricity generated in the United States. And this efficient energy sources comes from the 98 nuclear power reactors, dotted around 30 different states in the US. The stable production of power created by nuclear power plants, which means that it can ideally be used in conjunction with other forms of renewable energy. So for example, wind turbines generate significant amount of power when the wind is blows. When the wind is blowing, nuclear plants can adjust energy output to be lower. Nuclear energy can be adjusted to compensate for the lack of wind or solar generated power. Fourth, produces low pollution when it comes to pollutions. It's clear that there are pros and cons of nuclear energy. And don't worry, we'll touch on the issue of nuclear waste in a moment. However, the overall output of pollutions from a nuclear power plant is quite low compared with energy productions from fossil fuels. The current consumption of nuclear energy already reduces over 555 million metric tons of emissions every year. And these reductions in greenhouse gases is a great indicator of how switching to nuclear energy can help reduce our effect on global climate change in the long run. Number 5. Sufficient fuel available like fossil fuels. The uranium used to supply nuclear power plants is in the limited supply. However, our uranium reserves are estimated to last another 80 years, whereas fossil fuels have a much more limited lifespans. Since the Industrial Revolutions, we have been consistently and constantly depleting our fossil fuels reserves. If we continue consuming fossil fuels and keep increasing our consumptions, as the world population grows, we are estimated to run out of oil by 2052, and gas in 2060, and coal by 2088. And of course, there are more fossil fuel discoveries we have yet to make. But they are fewer and farther between than ever and will eventually run out. Switching to uranium might give us the extra time we need to find better and cleaner renewable energy resources. Plus, some countries like India, China, and Russia are already working towards using the greener and more abundant thorium to power nuclear reactors. If we switch to thorium, we will have even longer than 80 years of fuel available. However, if scientists are able to turn nuclear fusion into a reality, we would theoretically never run out of electricity ever again. Turning nuclear energy into sustainable energy requires the use of breeder reactors and nuclear fusion to sustain us for the foreseeable future. Number 6. It has high energy density in our list of the pros and cons of nuclear energy. And this pro is quite astounding. So the nuclear fission, the process used to generate nuclear energy, releases much greater amounts of energy than simply burning fossil fuels like gas, oil, and coal. But how much more efficient? Nuclear fission is nearly 8,000 times more efficient at producing energy than traditional fossil fuels. That's a considerable amount of energy density. And because nuclear energy is more efficient, it requires less fuel to power the plant and therefore creates less waste as well. So, and here is the negative impact of nuclear reactor in the country. First is the expensive to build despite being relatively inexpensive to operate. So nuclear power plants are incredibly expensive to build, and the most keep rising. From 2022 to 2008, the estimated cost to build a nuclear plant grew from $2 to $4 billion of $9 billion. And the power plants often surpass their cost estimates during construction. In addition to the expense of building a power plant, a nuclear plant must also allocate funds to protect the waste they produce and keep it in cold structures with security procedures in place. And all of these costs make nuclear power quite expensive. Second, accident. One of the first thing most people think of when they hear nuclear power plant is the disaster at Chernobyl. Although we don't know exactly how many people died as a result of the Chernobyl incident, it's estimated that there has been as many as 10,000 deaths from the long-term effects of radiation in the region. The Fukushima power plant crisis in 2011 showed that no matter how safe nuclear power plants are designed to be, accident can do happen. Number 3. Produces radioactive waste. Although nuclear energy production does not create any emissions, it does produce radioactive waste that must be stored so it doesn't pollute the environment. While radiation might sound scary, we are constantly exposed to small amounts of radioactivity from cosmic rays or radon in the air we breathe. So in small quantities, radiation isn't harmful, but the radioactive waste from nuclear energy production is incredibly dangerous. Storing of radioactive waste is a major challenge facing nuclear power plants because there is no way to destroy nuclear waste when the current solution is to sell it securely in containers and store it in deep underground where it can't contaminate the environment. As technology improves, we will hopefully find better ways of storing radioactive waste in the future. And number 4, impact on the environment. Nuclear power plants have a greater impact on the environment than just the waste they produce. So the mining and enrichment of uranium are not environmentally friendly process. Open pit mining for uranium is safe for miners, but leaves behind radioactive particles, causes erosions, and even pollutes nearby sources of water. Underground mining is much better and exposes miners to high amounts of radiation, while producing radioactive waste rock during extractions and processing. Number 5. Security threat. Nuclear power presents a unique threat to our national security because it is powered by nuclear energy. Terrorists might target nuclear power plants with the intention of creating a disaster, and the uranium used to produce the power can be turned into nuclear weapons if they end up in the wrong hands. For these reasons, security surrounding nuclear materials and nuclear power plant is extremely important. Number 6. Limited fuel supply. There might be some important pros and cons of nuclear energy, but one of the most important considerations to keep in mind is that nuclear energy is dependent on uranium and thorium to produce energy. Unless we can find a way to create a nuclear fusion or build breeder reactors before our supply dries up, and we will be unable to create energy with the nuclear power plants we built for the future. Ultimately, nuclear power is only a temporary solution with a very high price tag. Conclusion. Learning about the positive and negative impact of nuclear in the country will help us decide whether it is a good choice for our future energy needs or whether it is not a long-term strategy worth pursuing. Nuclear reactor might be one of the most controversial energy sources we have. For some people, the potential risk is associated with nuclear looks like the answers for a zero-carbon future. But we can deny that it also brought negative impact to the country. And that would be all. Thank you, I hope. Any questions?